Hi everyone, welcome back to the channel. In this video today we're going to be looking at the Heaviside Step Function. This is a function that deals with discontinuity, and the purpose of this is eventually we're going to see how we can use the Heaviside Step Function in order to solve a differential equation using Laplace transforms. So let's see how this goes. So the Heaviside Step Function is defined as a function u of t minus a, and that is equal to two values, 0 and 1. 0 where t, and that's this t over here, is less than or equal to a, and where t is greater than a, it would be equal to 1. And the a is a constant, where a is greater than or equal to 0. So now what we're going to do is, in an example, I'm going to show you how to convert a Heaviside step function into a discontinuous function, and then also to graph that function. So let's have a look at the example. Now from the definition of the Heaviside function, you'll see that it acts almost as a switch, right? So there's something happening at that t equals to a. So if you look at the function that we've got here, you'll see we've got three different functions. So let me just change the color here. So this is a Heaviside function, that one, and that one there, right? Let's just do this over, and this one here. And for each of these, something is happening where t equals to 5, where t equals to 10, and where t equals to 15. So what I'm going to do is I am first going to write out the definitions for each of these functions. So I'm going to take u of t minus 5, and that is equal to either 0 or 1, and we're going by the definition of the Heaviside function now, where t is less than or equal to 5, and where t is greater than 5. Okay, so that's for the first one. The second function, which is u of t minus 10, let me just move this so that you can see, is going to be equal to either 0 or 1, where t is less than or equal to 10, where t is greater than 10. And then the last one is going to be where u of t minus 15 is equal to 0 or 1, where t is less than or equal to 15, t is greater than 15. So if you look at the definition that I've used here, the way I've laid out this function, if you compare it to the definition, you'll see all I've done is, so for the first one, you've got a 5 where a is, right? And then I replace the a values here in the definition, okay? So now I'm going to try to graph this function. So if I look at, let's take, let me do the graph. So I have intervals on my graph. I have 5, 10, and 15. Right? I've got those three. So the first interval that I need to work out what's happening to the function is between 0 and 5. So I'm going to say where t is between 0 and 5. What happens to f of t? Right? And you remember our function is defined as 2u t minus 5, 3u, let me move myself again, t minus 10 plus u of, let's just move this over, u of t minus 15. So, remembering that your t value here can only be between 0 and 5, right? So then what does that mean for u of t minus 5, right? T is less than 5, which means if I go back to this one here, you see t is less than 5, which means that u of t minus 5 has to be 0. Right? T is less than 5, which means u of t minus 10 also has to be 0 because of this constraint there. And u of t minus 15 also has to be 0 because of that constraint. Which means, if I look at what's happening to my function, it means that this piece is 0, so it's going to be 2, that's 0. This piece is also 0. And that piece is 0, which means that everything, this entire function is going to be 0 between t equals to 0 and, well, t in between 0 and 5. Which means if I graph it, the graph is going to look like that, right? Because it's 0 there. Let's just add in here, the function we're looking at is f of t. Okay, so now the next interval we need to look at is between 5 and 10. So then, just move this one up. So we're looking where t, not 0, we're looking between 5 and 10, right? And the function again that we're looking at is f of t. It's just easier to write this out so you can think, you can see clearly what it is you're doing. T minus 10, t minus 15. Okay? So then, t is in between 5 and 10. So when we go back to the definitions of the Heaviside functions we're using, you'll see that u of t minus 5 is now going to be 1, right? Because the t bracket we're working with is greater than 5. Here, u of t minus 10 is going to be 0 because t is still less than 10. U of t minus 15 again is going to be 0 because t is less than 15. So that means that we're going to have 2 times 1, 3 times 0 plus 0, which means your function f of t is going to be equal to 2. And if I graph that, it means that this function has to be 2. Right? It has to be 2. And that would be 2. Okay? So you can see, as I said, where you have t equals to 5, right? Something happens. There's like a switch, right? Or increase or decrease, or the function changes basically. So then the last interval, well, not the last, the second last interval we need to look at is between 10 and 15. So if I look, we are now looking where t is in between 10 and 15. So what happens to your function f of t? So you've got 2 u of t minus 5, 3 u of t minus 10, u of t minus 15, right? 2 times u of t minus 5. So t in this case is bigger than 5, right? So when you compare to the definition of the u of t minus 5 function, you know that that's going to be 1, right? If I look at u of t minus 10, you see we're working between 10 and 15, which means t is greater than 10, which means that u of t minus 10 has to be 1. So then that has to be 1. right? U of t minus 15, t is still less than 15, which means that the Heaviside function has to equal 0. Right? Which means that is going to be 0. And that means that f of t in this interval is going to be minus 1. Right? So if I graph that, it's going to be, it switches from positive 2 to minus 1, like that. Right? And that is minus 1. Okay, now the last interval that we have is where t is greater than 15. Let me just label this axis so you know which one we're speaking about. So that is the t-axis. So we then write, we're looking where t is greater than 15. So what happens to your function f of t? Is going to, let's just write him out again. Right? So what happens here? 2 u of t minus 5. T is bigger than 5, which means that that function is going to be a 1. So that stays 2. U of t minus 10 is also going to be 1 because t is greater than 10. So that's times 1. U of t minus 15, if we look at the definition of that function, right, where t is bigger than 15, u of t minus 15 is also 1. Right, which means that it is 1 over there. So you're going to have 2 minus 3 is minus 1 plus 1, which means your function is going to be 0 at that point. And if we graph that, it's going to look like that. And it's going to continue being 0, right? Because t is bigger than 15. There's no constraint there. Okay, so now that you've got the graph, you can convert this into the discontinuous function, the notation for the discontinuous function, which I'll show you now. So when writing this discontinuous function, you'll see that your function is divided into 4 pieces. So we write f of t is going to be equal to 4 different values, right? We have it equal to 0. First part is 0. And your t value here is between 0 and 5. So it's going to be between 0 and 5. Then between 5 and 10, it's going to be 2. That must be 5. And 10. Between 10 and 15, it's going to be minus 1. And bigger than 15, it is going to be 0. Right? Let's just lower this bracket a bit and put in our equals to sign. So this here is the discontinuous function for f of t of 2 times u of t minus 5 minus 3 of u t minus 10 plus u of t minus 15. Okay, so we've converted f of t, which is in terms of the Heaviside function. We've graphed it like that. We've then converted like that. I hope you found that video useful. Please let me know what you think in the comment section. And if there's anything else you'd like to add. I'll see you next time. Bye.